6.2 Indefinite Integrals. So in this video we're going to talk about how to solve some indefinite integrals where the u sub is not given to you. We're going to mostly focus on u subs that don't require too many tricks. They're going to be pretty straightforward. If you're following the textbook, it's number 25 through 35 in the book. Alright, number 25. This is the integral of dx divided by 1 minus x quantity squared. So this is where we need to do a little bit of rewriting to make the problem a little bit easier. So I'm going to rewrite this as the integral of 1 over 1 minus x squared dx, just to show you the dx is off to the side. So now we're going to do our u sub. I'm going to let u equal, and I'm going to let it equal the inside of that parentheses, 1 minus x. I take the derivative of both sides, and I get du is equal to negative dx. And from here, I don't need a negative dx, I just need a positive dx. So then I'm going to multiply both sides by negative 1 to get negative du equals dx. So now I'm going to rewrite my integral using my u sub. This is going to be the integral of 1 over u squared times a negative 1 du. So this is negative the integral of u to the negative 2 du. And from here, I'm going to get a negative. When I integrate u to the negative 2, I'm going to get negative u to the negative 1 plus c. This comes because I'm dividing by a negative 1 because the new power is negative 1. So I'm going to rewrite this as a negative and negative, make a positive. So 1 over u plus c. And then I'm going to put my 1 minus x back in for u plus c. And that's it. Alright, number 26. So this says the integral of secant squared of x plus 2 dx. Right away, I know that this is going to be a problem. So I'm going to let u equal x plus 2. So then I get that du is equal to the derivative of x plus 2 is just 1. So just dx. So nice and easy u sub. So I get this is the integral of secant squared u du. So this is going to be the integral of secant squared is tangent. So tangent of u plus c. And then I have to put the u back, so I get tangent of x plus 2 plus c. Alright, moving on to number 27. I get the integral of the square root of tangent of x times secant squared of x. So this is a lot of mess. I can see, though, that the derivative of tangent is secant squared. So I'm going to let u be tangent of x. And I get du is equal to secant squared of x dx. Well, that's really nice and handy because I have all of that right here. So now I'm going to rewrite my integral as the integral of the square root of u du. I find it's very helpful to write this as to the power of 1/2. And from here now I'm going to integrate, and I'm going to get u to the 3/2 divided by 3/2 plus c. And this is going to give me 2/3 u to the 3/2 plus c, because when you divide by a fraction, you multiply by its reciprocal. So this is going to be 2/3. And my u was equal to tangent of x to the 3/2 plus c. All done. Easy peasy, lemon squeezy. Alright, moving on to number 28. We're ripping through these pretty quick. As far as u sub goes, these ones are not bad. Okay, so I'm going to look and I'm going to see, oh, this is a nightmare. Well, I noticed that that's pretty gross. Let's get rid of it. Because I know if I just had secant of u times tangent of u, the integral is just secant. So I'm going to go u is equal to theta plus pi over 2. Do not let this mess you up. The variable here is theta. Pi over 2 is a constant. So I'm going to take the derivative of both sides and get du is equal to the derivative of theta is just d theta. And the derivative of pi over 2 is just 0 because it's a constant. Nobody cares about pi over 2 in this case. So I'm going to rewrite my integral as secant of u times tangent of u du. And this is going to give me a nice an easy secant of u plus c. And so this is secant of theta plus pi over 2 plus c. Again, pretty easy. All right, moving on to number 29. Number 29, we have the integral of tangent of 4x plus 2 dx. Again, inside the parentheses, I want that gone. Set it equal to u, take the derivative. You get 4 dx. Here's the problem. You don't have a 4 dx in your integral, but that's okay. We just divide both sides by 4. You get 1/4 du equals dx. We're going to go ahead and now do our u sub. And we're going to get this is the integral of tangent of u times 1/4 dx. Notice that the, oops, I'm sorry, not dx. What am I saying? Du. Because dx is equal, this whole thing is equal to 1/4 du. Alright, now all we gotta do is integrate. So I'm gonna go ahead, before I integrate, I'm gonna throw this 1/4 on the outside because it's a constant. So this is where it gets a little tricky. You need to know a very special integral. The integral of tangent is going to be negative ln of the absolute value of cosine of u. This one you just kind of have to know. So you're going to get negative 1/4 ln the absolute value of cosine of u plus c, and then we have to put back our u sub. So this is ln of cosine of 4x plus 2 plus c. That one, I'll give it to you, is a little tricky. Alright, moving on to number 30. So in number 30, we see 3 times sine of x to the negative 2 power. So this one actually does not require a u sub, it just requires a little manipulation of the problem. So this is going to be equal to 3 times the integral of, and I'm going to write it as 1 over sine squared of x dx. There's a couple ways you can approach this. You can rewrite it as, 1 minus cosine squared, but I think this way I'm going to show you is probably the easiest. This becomes 3 times the integral of cosecant squared of x dx. And we all know that the integral of cosecant squared is going to be negative cotangent. So this is 3 times a negative cotangent of x plus c. So you get negative 3 cotangent of x plus c. And we call it a day. Alright, we're trucking along. We're on to number 31. Number 31 says the integral of cosine of 3z plus 4dz. And so this is going to require a u sub. How do I know? That's the question. Well, I have a nice little inside piece I just wish wasn't there. So u is equal to 3z plus 4. So du is going to be 3dz. Notice I only have a dz. I don't have a 3dz. So I'm going to multiply both sides by 1/3 or divide by 3, whichever way you like. Now I'm going to rewrite my integral using the u sub. So this is cosine of u times 1/3 dz. So this is going to be 1/3 times the integral of cosine of u. I'm sorry, it's du. Keep making that mistake. Du. So now we integrate, and you're going to get 1/3 sine of u plus c, which is equal to 1/3 sine of 3z plus 4 plus c. Alright, moving on to number 32. The integral of the square root of cotangent of x times cosecant squared of x dx. So we notice a definite derivative integral relationship here, where the derivative of cotangent is negative cosecant. A little hint there, whenever you hear the word co in derivative or integrals, it usually means there's a negative involved. So u is equal to cotangent of x, so du is equal to negative cosecant squared of x dx. So negative du is going to be equal to cosecant squared of x dx, which is really nice because it's all right here for us, ready to go. So this is equal to the integral of the square root of u times a -1 du. So this is negative times the integral of u to the 1/2 du, which is equal to negative 2/3 u to the 3/2 plus c. So I'm going to get this as negative 2/3, and my u was cotangent of x to the 3/2 plus c. Do not forget that plus c. It is very, very important. All right, moving on. Number 33. We only got 3 problems left to go. Almost there. So right here, this is an absolute mess. Let's rewrite it and make it a little nicer. So this is the integral of ln of x to the 6 times 1 over x dx. And the reason I wrote it out like this was hopefully to make the u sub a little more clear, where u is going to be ln of x. Again, it's this inside piece. And then du is 1 over x dx. And look at this. Look how great that is. Everything lines up. Everything is fantastic. So we rewrite our integral using our u sub. This is u to the 6 times du. And the integral of u to the 6 is going to be u to the 7th over 7 plus c. And this is equal to 1/7 times ln of x to the 7th power plus c. All right, number 34, here we go. Oh, this looks pretty gross. We got tangent to the 7th, secant squared, some x over 2's. This thing is nasty. What makes it nice, though, is we can get rid of a lot of it pretty quick. If you know what to do, I really strongly recommend trying this one yourself. If you don't know what to do, that's okay. Here we go, the u sub. U is equal to tangent of x over 2. So then you get du is equal to secant squared of x over 2 times 1/2 dx. This is because of the chain rule. Well, notice I do have most of this right here. I just need to get rid of that 1/2. So I'm going to multiply everything by 2. Get secant squared x over 2 dx. Now see right here, now they match all perfect like. So I'm going to rewrite my integral as u to the 7th times 2 du. This is going to be equal to 2 times the integral of u to the 7th du. Now we integrate and we get 2 times u to the 8th divided by 8 plus c. So this is 1/4 u to the 8th plus c, and we get 1/4, and our u was tangent of x over 2 plus c to the 8th power. Don't forget the 8th power. All right, last one. Time for the home stretch, number 35. And number 35 does look like a doozy. But that's all right. We can do it. I highly recommend to just do a little bit of rewriting. I'm going to write this as cosine s to the 4/3 minus 8 times s to the 1/3 ds. And the way I am able to see that so quickly to rewrite that is just experience. I've done a lot of integrals. You'll start picking up on it as you do more. So this is u is equal to, again, the inside piece, s to the 4/3 minus 8. So du is equal to 4/3 s to the 1/3 ds. Notice I do have most of that. I just want to get rid of that pesky 4/3. So this is 3/4 du is equal to s to the 1/3 ds. What I'm doing here is I'm multiplying by the reciprocal of 4/3 to get it to cancel. All right, here we go with our u sub. This is equal to the integral of cosine of u times s to the 1/3 ds. All of this is all equal to, you guessed it, 3/4 du. So this is 3/4 times the integral of cosine of u du. And the integral of cosine is just sine, so you get 3/4 sine of u plus c. And now we're going to put that u back and get sine of s to the 4/3 minus 8 plus c. And bing bada boom, we're all done.